Welcome to Numbers and Strings. In this session, we are going to look at numbers, but moving downstream in our discussion, we will talk about more things like strings, characters, and autoboxing. So welcome to this part. Primitive examples that we already know by now from the previous sessions is int, the data type like int, byte, short, int long, float, double. So we are going to focus on numerical data types in this case, and you get to put their name, then you assign a value to them. Like in this case, it's a value 500. Now there are some times where you might need to work with wrapper classes for the data types, for the numerical primitive data types. So when you want to do that, Java has provided an API in the java.lang package called Number. And Number has several subclasses, as I'll show you in a bit. So in this example, we will look at byte, integer, double, short, float, and long subclasses to represent the byte, short, int, long, float, and double primitive numerical data types. If you go to the Number API, I will attach this in the description. You will see that it has direct non-subclasses as shown here. What you will not do is to look at atomic integer, atomic long. If you want to know more about that, you can just click on the link here and it will redirect you to the same. We will not look at big decimal and big integer, which were designed for precision. For example, if you're working with an application where you need to work with the money, financial kind of data, then you might you should actually decide to work with big decimal and big integer. What we'll do is to look at byte, double. We will not talk about double accumulator and double adder. If you want to know more about that, then again you can just click on the link. It's pretty much self-explanatory. If you click on the links and read through the API. We look at float, integer, long. We won't look at long accumulator or long adder. If you want to know more about that, then you can again do as I've said before, or work with your favorite AI who knows what your approach would be. And we also have short. Okay, so this is the class that we will focus on, and we will look at the reasons why you might choose to work with this class and its subclass methods as a result. So the class in itself has these methods, but most of the time you'll work with the subclass methods. The examples specifically that we'll work with are the integer examples, but they are pretty transferable to the other types of wrappers like byte, double, float, long, and short. So going on to the number, I will walk you through an example in code that will show you the use cases of these methods from the subclasses of number. So just to pull up IntelliJ with the code examples, we have number example class here. I'll not attach this GitHub link or a link to GitHub for this code. It's very simple. You can always recreate it, and I'll also guide you on how to go about this. We've not covered collections yet in these sessions, but we will be covering it later. However, I'll have you know that when you're working with collections, you need to work with object types of primitive data type. So like in this example, we're working with an object type number, and number in it, as you've seen, has subclasses for different primitive wrappers for different primitive data types. So that means you can add an integer, you can add a double, a long, or a float, and the other types too. We are creating a number list here. Then we are adding those different supported data types in that object. So this introduces us to the first instance where we might choose to work with wrapper classes over primitive data types, and that is when you want to pass in an argument of a method that is expecting objects, yet you are currently working with primitive data types like 42, 3.14, and so on. So I have a display numbers method in my code, and I'm passing in numbers list. Because of that, numbers list here will be objects, a list of objects. So display numbers is right here in my code, and it is expecting a list of the object type numbers, and it's iterating through the same when it's called. So you can work with for each. We'll talk about this in collections, but because we are not yet there, let's look at a brute force way of doing the same, which is to work with the for loop that iterates through a collection. So we have numbers here, which is a list of object numbers, and we are iterating through it by calling the number here, get class on that, and get the simple name of the same. So what I'll do then to demonstrate this is to comment out the rest of the code. So we are left with the bits and pieces that we are currently working with, which is this part here. So if I run this, I expect to see what was added. And here you go. Please ignore the warning. I'll deal with that much later. So we have 42, 3.14, 100, and 2.5. And as per the method display numbers, what happens is it's iterating through the numbers list, and it's going to append number string to the number itself and the type to the type itself. So the way to access the type is to call number, the current iteration, get class of the current iteration, which is in this case the first instance an integer is shown here, then get the simple name of the same, which is integer. So if it's a double, then we'll see that long and float. So we are handling that in the display numbers method, and the main method we can then pass in the number lists number. Great. The other instance that you might consider to work with the wrappers instead of primitive data types is when you want to work with constants that have been defined within a class. For example, min value and max value constants that are supposed to fetch the minimum value and the maximum value. So we are working with the integer. So if I run this, then we'll expect to see the minimum value, the maximum default values of integers, which are as shown here. However, you'll still get the same results if you're working with the double, because double class also has similar constants. There are some differences here and there, but it's something you can always walk through and get familiarized with. So I'll just go back to the code and show you more reasons why you might decide to work with wrapper classes. So if you want to make use of the methods, because they come in ready with conversion methods. For example, in this case, if you have a number value and you need to convert it to its primitive data type, like its int value or its double value or its float value, then you can work with those methods, and indeed you will see the primitive data types of 42 as specified. So the primitive data type of 42 is 42. The primitive data type of the primitive data types of double of 42 is 42.0, and same applies for float value. There are other methods available, like the compare to methods that might compel you to work with the wrapper classes. So we have the compare to method. For example, in this case, we are comparing the integer 30 to passed in value 100. We expect this to give us -1 because that is not true. However, if it were true, we would get a 0. So if I change this to a value 30, then it will change that into a 0 in our output. Okay, other methods equals method. So if I work with this method, then it will help me check if the integer value 30 is equals to the number passed in, and the number here being 42, which was created earlier on. in our main method. So if I run that, I expect to see false because definitely 42 is not 30. However, if I pass in 30 and check it out, then I expect to see that it is true that 30 equals to 30. Please note that there are some differences here and there in the equals method with the double and the float as compared to the integer. If you want to know more about that, please go to the doubles API and learn some more. So what you need to do then is to use the link in the description that takes you to the double API and check out equals. So you'll see some explanations here and you can practice it out to see the differences between that and int. Okay, back to our code. So with the decode method, it helps you decode the value of a passed in string. So it could either be a decimal, octal, or hexadecimal number. So if I run this, then it will decode whatever string has been passed in to its integer value, and in this case we are seeing the decoded integer is 42. The next method is passInt, and passInt converts whatever value has been passed in to its integer value. So in this case, if it's 42, then we get 42. If I pass in something that makes no sense, like out, then I don't expect to see something very fruitful. I'll see this exception here. So it has to be something that can be converted into an integer or integral value. If we check out more about the same, let's say you're not working with the decimal value because the decimal value is the default one. If you want to work with other radix types like a decimal value, a binary value, an octal value, or a hexadecimal value, then you can pass in the respective radix to represent the type of value that you want to work with. So in this case, if I pass into A, then I'll specify that it's a hexadecimal value, and I will see the hexadecimal integral value of the same, which is 42. Other things you can do, so there's a lot of interesting things. What I'm trying to demonstrate here really is that there's a lot of interesting things you can do with the methods in the classes in the API. For example, if you wanted to print this out here to binary string, if you wanted to convert the passed in value to binary string and you run that, then you will get the string value of the passed in value in binary form. So if it's 42, then the binary form then is 101010, and the same will apply for whatever value that you pass in. Other things that you can do or other methods that exist is a value of. So if you want to get value of the passed in string, then you'll expect to see 42. So it's returning an integer object from whatever string was passed in. If you want to get value of 42, and you pass in 42 as a primitive int, or rather a primitive data type int, then it will return integer object from the primitive that was passed in. Value of also supports octal, binary, or rather it supports radix of 2, 10, 8, or 16. So if you run that, then you should get the respective output. All of these amount to 42. However, no one is tying your hand on this. If you want to practice some more, you can work with the reference links in the description. There will be a reference link to this source because we've looked at examples provided in the source. There will be a reference link to the integer class, a reference link to the double class, a reference link to the numbers class. Please find time to practice with that. That's it for the numbers session, but there There are upcoming sessions on the same. We'll look at formatting, which you've already seen bits and pieces of from print line and so on. And then we'll proceed on to talk about other things in the same numbers and strings discussion. So see you on the next one.